Hello and welcome to another edition of the EWI Technology Podcast. Here we are in beautiful Columbus, Ohio on a cold, snowy day, which reminds me of my hometown in Canada. But we have been having lots of fun interviewing people all day and this week on a number of amazing topics. Today, right now, I have Ryan Gneiting here with us, who is our senior automotion engineer. Ryan, how you doing?
I'm doing excellent. Thank you.
Good. How are you liking today?
It's been great. We've got our 40th anniversary. We celebrated it today.
Got some pizza.
Oh, yeah.
It was good. It was good. People were telling me it was good pizza, and they were right.
A little bit of swag, too. So,
well, we didn't get the swag.
No swag? All right.
I asked about the swag, but I don't think us CWBers count.
We could have put your name on the list, honorary.
Well, if there's any extra double XLs, hey, shoot them my way. So your title here, as an automation engineer, that's a big part of EWI, and I think of industry in general represented, but the push and advancements into the automation and cobot industry.
Yeah, we EWI has been our history is a lot about process and process settings, getting the best process for each application, and part of that is now not just the process itself, the things doing it, but how do you
get there?
Yeah.
Now, how long have you been with EWI?
Been with EWI 2 years.
2 years? Oh, so you're, I saw all the things up today. You're a baby in the company compared to all the 30-year people.
I am, but got a lot of good folks on the team. We've got an automation team in Buffalo. Got some automation folks here. Also, our automation team or group kind of is like a blanket. It covers all aspects. So all of those processes we talked about, automation helps support or stand those up or improve them and take them to the next step.
Well, I've been to the lab in Buffalo, and it was impressive, and I haven't quite gotten a tour here yet, just been too busy. But, in terms of you coming here, what brought Ryan to EWI to do this work?
The opportunity to further my knowledge. I came to EWI with 23 years of welding experience. My degree by background is a weld engineer. My knowledge through welding and through industry has shifted from welding into automation, and that shift or that journey took place 20 years ago.
Yeah.
As a young weld engineer, I realized that most welding is done by robots, so I better learn it and know it. And I've come to learn, know, and love automation, robotics.
Well, it's interesting, because you say you've been in this industry for over 20 years, specifically into the robot automation side of welding. What changes? Like, how much has it changed in 20 years? Like, I know, I've seen amazing advancements, but from being on the inside of it on your end, how much has it moved?
The mechanical arms themselves, they've been around since the 60s, 70s, 80s, started out with hydraulics and fluid motion. And then eventually, got into a lot of your 6-axis type mechanical linkage, servo in the 90s and, early 80s, 90s. Not a lot changed until a lot more of the ancillary or supportive structure around robotics.
Right.
How they're programmed, some of the sensing software and suites of software around them.
And has there been much changes? Like, when you look at the classic robot, and it's got the arms and it's articulating and it's got a certain reach, that hasn't changed too much because it's kind of a type of machine. But you talking about the support systems around it. And that's, I think, where I've seen a lot of the changes, where it's not just the robot for the welding, but it's the robot for the picking and for the setting and the getting it on the conveyor and getting it down and then removing it, fixtures and supports and sensors and all these things have kind of evolved around that machine.
For sure. And, my journey, already mentioned, started out in the welding space, and it was getting these welding systems to be smarter.
Yeah.
Working with weld manufacturers or weld equipment manufacturers to say, hey, you know what? You're outputting a voltage, you're outputting a current, some process parameter. let's give a little bit of that information back into the robot to make it smarter.
Mm-hmm.
Well, hey, if I know the voltage or the current, maybe I can know to go left or right or go higher, go lower.
Yeah.
Some of this adaptive kind of technology slowly started to come in to play, in the 90s, 2000s, and it's just gotten better, much more advanced, easier to program.
Oh, yeah,
that's
for
the
sure.
big thing. is if you need a PhD or be a scientist to do it, we're not going to the moon.
Well, and sensors, the sensors that have been developed to help guide the automation, I've seen just progress incredibly too. That data that's feeding back and how it's coming back in. And, now they talk about machine learning, right?
Oh, yes.
How the machine can actually make decisions based off of the input and the adaptive welds. I've seen some of them, like they throw a piece of plate on the table and the machine figures out where it is and what it needs to do. And that's amazing, right?
It is. But what they don't tell you is, it's kind of like you go to these trade shows, these demos.
Yeah.
You see the 5 or 10% of the time
Mm-hmm.
that it took to get the actual demo or get it perfect. What you don't see is the 80 to 90% of the tries before that.
Yeah.
Where you have to work at it and get it. Is the sensor calibrated?
Mm-hmm.
Is that the right part? Hey, we didn't teach that part, and right now it's not smart enough to know that
that's not the right one.
That's not a part. So.
Well, that's actually a super interesting concept. Let's talk about that, in terms of the ease of delivery. How much has that changed? Because I remember the first automated machines that I worked with actually had punch cards. Like I've been welding since 93, right? And now you're talking about cobots that have like safety sensors that you can just like grab it, say, copy me, and it takes that information. That's within 30 years. How much has that whole world been, made easier?
Extremely. The ability to program. The whole goal of the automation or the robot system is to put the end of something close to or near and something else and do something, whether that is, welding, dispensing, grabbing, gripping. And that technology, that capability to get it there better, faster, easier. Mm-hmm. These cobots have made it such that you don't have to know some programming language. The first, you don't have to know like a Fortran was. Yeah. Fortran was what I
G-code.
When I was here in Columbus going to school. The first program language I learned was Fortran. I didn't even use it after that.
Yeah. Although I do argue that knowing program language is beneficial just for understanding how a robot thinks.
Yes.
Right? Because even if you're not programming it, it's still thinking in those terms.
Yeah, it's right? This logic flow,
it's
this
logic,
statement.
Yeah.
Like, okay, if, then,
go
now.
to. Yeah.
Yeah.
Yeah. One of the things you said is that, you don't see the 80% of time that goes in behind the scenes to make the demos or to make that piece work. And I think that that's fairly accurate in terms of what I've seen. I worked in the manufacturing industry for ag, and we had quite a bit of automation within our facility. And the first serious length of time was spent just figuring out the fixtures, the welds, the processes. And sometimes you're talking a month before you're actually ripping parts off, right?
Oh, yeah.
And then those first batches, there's X amount that are wrong, and you got to reassess and redo. And I think a lot of people maybe don't understand the back end of automation, and that it's not just calling up X company saying, I want to be automated, and they come in and by next week you're automated, right? There's a whole process. Yeah. What's that process like?
That usually starts out with, some kind of statement of work or process parameters, some development of that, functional requirements, not only requirements of what the process, the part, procedure, the manufacturing is, but also knowing the capabilities and the requirements of the equipment needed to do that. So you usually will do some type of manufacturability study. Sometimes it's a value stream map, if you've ever heard of those.
Yeah, lean, yeah.
So you're looking at, okay, what exactly is really needed
Mm-hmm.
versus what can I cut out? What is that waste that is not really needed? And it's usually how do we cut time out of it?
Mm-hmm.
So then you'll bring that in. A lot of times we'll use some simulation environments too, as you're building and designing a cell. What kind of robot arm do I need? Something short? Do I need something long? Do I need something that can pick up a Corvette, a car, or it just has to pick up this little,
Doodad, a widget.
five
Yeah.
widget. And so you're in that design space. Is a lot of the things that we as automation engineers or applications engineers is what some of the industry will call it if you work for a system integrator or at one of these large ag kind of manufacturers. I started my career with a large ag and construction company, working additionally on welding systems, but got into collaborative robots, got into smart vision systems, even got into some mobile robot systems.
Oh yeah. That's still a struggle. The mobile world for robots. I feel like that's one of the ones that hasn't quite kept up to the other, types of advancements in the robot world.
Yeah, it's new to the space. Depending on who you're talking to, Adept robots were some of the first, medical robots in hospitals.
Yeah.
But they are a lot of, as you talked about. Hey, where do you start? How do you know what to do? And a lot of it is laying out where those values are, that value add, and knowing when to use the right tool. Is this mobile robot? Is this cobot? Or should I go with a traditional robot that has to be guarded, fenced?
Yeah.
And so we help often make those decisions for people or help guide them through that decision matrix of, hey, these cobots, I'm getting told all about them. Is that the right way to go for my case, my situation? Or should some of the traditional robotics that are out there, because of its capabilities, is that better? And nice thing is that line of which should I pick used to be fairly clear, but it's blurring now.
Mm-hmm. So I was going to bring that up, because to the layman, what's the difference between a traditional robot that you talk about and a collaborative or a cobot? What is the striking difference, and then where is that blurred line?
It's mainly how close do you need an operator to be near the robot. Mm-hmm. These collaborative robots, and I sit on some industry standards committees, one of which is RIA A3 R1506 committee. It's a safety committee, and we are wanting to talk more about collaborative applications than actually cobots. It's going to be really hard for the industry. They are labeled cobots, and they probably will be forever. Yeah. But we like to talk more about collaborative applications.
Okay. Yeah.
I know your question was more about cobots. So while we're on that space, what the difference of those cobots versus traditional? It's mainly, how close do you need to be to that robot while it's performing its application?
Right, because a traditional robot, there's no user nearby. It's a dangerous space. You have light curtains. You have dead man switches. You have a whole. But I guess the question is, why can't you just use a cobot in that same situation? Why would you not just use the safe one for everything?
Cobots are safe if applied right.
Mm-hmm.
But why you may not use that cobot for everything, or traditional, mainly why not use that cobot? Because, hey, I don't need fences, or I perceive that you don't need fences. Yeah. It's usually because of either a reach or a payload.
Okay.
And often speed. So with these cobots, the thing that makes them safe is that there's a reduced speed. Usually it's 250 millimeters per second. Mm-hmm. That is a speed that generally someone, if something is approaching you,
you can react to it.
You can react to it and get out of the way.
Mm-hmm.
It then also has the added capability, and each cobot company does it themselves in a different way. They
press reaction.
They have some type of force, you know, maximum force that could be applied, and
it'll trigger them off. Yeah,
trigger that off, and it's those forces, if applied correctly, you know, through a risk assessment, should not breach the threshold of pain.
Right. Okay.
You have different.
And a traditional robot, the one that people think you could have a much larger payload, much bigger reach,
much faster.
Like if they
you
can
need
just
to get
whip
those widgets out,
Yeah.
traditional robots, you know, what's your cycle time? If you need one an hour, hey, yeah.
But they're generally mounted, singular in use. They're going to be doing the one thing for a while until you reprogram it to do the next thing. Whereas a cobot, I feel like at any whim, I could say, you know what, let's do something else, and it's not going to be that much, not that onerous of a job to reprogram, right?
Yeah, depending on the task and the program. If they're simple tasks and programs, you know, it's easy to grab them and say, hey, do your thing here, here, and here, and teach. You can't do that with a traditional robot.
No.
You know, there are some means and mechanisms to do that, but those are still in, you know, in the lower technology levels.
Yeah, the infancy stages.
Infancy stages, correct.
Now, in that blurred crossover area, are we seeing that the cobots or the collaborative applications are increasing payloads, increasing speeds, increasing reach, or the traditional robots are becoming safer with less programming? Because each has like their benefits, and as they blur, are they just kind of coming into each other's worlds?
Oh, definitely. It is getting blurred. Those cobots, a lot of them are now in, you know, I think you can get upwards of 2 meters of reach, 6 feet, 8 feet of reach.
Yeah.
You can get 35 kilograms, 60 pounds of payload on these. The strengths of the cobot are that drag to teach and this new approach to programming interfaces. It's applications or apps or wizards or drag icons.
Much more intuitive.
It's, you know, it's like you grab your iPhone or your iPad or your.
Let's do it.
You know, don't want to leave Google out, but yeah, whatever your choice is, Android. But it's, you know, a lot of these cobot companies, some of them have kind of this drag to teach on the pendant itself. You know, grab an icon, grab a statement, plug it in, work out your process flow.
And on the robot side, the traditional robot, are you seeing more of a push to becoming perhaps safer, bringing in some of these, or really at the end of the day, if you're going traditional, you want speed, you want payload, that's its purpose.
Yeah, that is its purpose, and the encroachment of the traditional into the cobot space, or the you know, the powerhouse. They are the legacy systems that are there. So all of this ecosystem around them
is built to support it.
It's built to support these traditional robots, and so now the sensors meant to guide and steer a robot were originally, many of them, built for traditional cobot programming languages. It's quickly getting ported over into the cobot space, but a lot of it was originally designed, built for traditional robotics.
So for somebody that's out there and listening in the industry, and they're looking online, and they're at the point where their business, you know, is ready to automate, which I think at this point, any young entrepreneur that's looking at getting into the welding space or manufacturing space should already from day one think about possible automation purposes. But as they look at this and they start thinking, well, what do I need? How do they start breaking that out for themselves? How do they start thinking, this is where I need this or that, or this is what I can automate? How does someone figure that out?
One of the starting points is, are you high mix, low volume? How many SKUs? Is it one SKU and you're doing thousands of them in a day, in a shift, in an hour? Or you have lots of things. If there's tons of widgets that need to be made and switched out and reprogrammed every hour, it's still difficult to get that low volume or high SKU count, low volume manufacturing programmed in automation. Automation is meant to do the same thing, the same time,
repetitive.
And so, looking at those areas that, hey, where in my factory or in my warehouse or manufacturing facility am I doing, you want to shoot for those tasks that are repetitive and you're doing quite often and quite frequent.
Mm-hmm.
So find those first. Those are the low-hanging fruit. Those are the easy ones. There's a lot of companies that have products and automation to service that. Start there first. Cut your teeth on that. Don't go for that slick sales pitch that
I've seen that happen.
There are companies out there.
I've seen a $7 million robot get bought, installed, and sit for a year.
Yeah.
You know what I mean? It's like, oh boy, let's do something with this thing.
Oh yeah.
Yeah.
So going out there, making connections. You can always come to, I'll give a plug for EWI.
Yeah,
you can always come here to, make those connections and understand, who's in the industry, what's out there, what's new, what's developing, and what's proven.
Yeah.
We like to say that we take out the
guess, the unknown.
Yep.
Yeah. Now, for you working here at EWI with your team, what is it that you are working on, and what are the things that you're advancing on right now that you're hopefully will be radical or improve the industry?
Yeah, you'll be talking to one of several of the team members, but one of the technologies is application.
The telewelding.
So being able to remotely control the automation from a safe distance.
Mm-hmm.
So there are some things where, for one reason or another, the application is not safe for somebody to be in, near, or around. Maybe it's confined space. One example that we've done is air arcing. If you've ever air arced,
I've done it a lot.
Air arcing is a sure sign when you're in a factory. I don't care if it's a half a mile long or if it's 2 miles long. When somebody starts air arcing,
everyone knows.
Everyone knows, and somebody messed up.
Yeah. There was a mistake made, and in the repair business, sometimes it's just wear, but it is a grueling task.
So that's one task where, okay, it's unique, it's different. It goes into that low volume. Mm-hmm. You do it once or twice, and it's a high mix, all kinds of parts.
Right.
And so those are harder to automate, but if you can give that finesse, that control of a human for those tasks, and take that, whether it's they're having to suit up, now they don't, or whether they have to carry some large application tool in air arcing, a large, heavy
and
torch.
120, 130 decibels, incredibly loud, right?
But you give that ability for them to control the process and have that human touch inside, and we always have the ability to record that. So if the volume or that amount of work on a part by part basis, hey, you know what? We've got 20 of these to do today. You teach it on the tele once, and then hit replay on the other 19 of those 20. Mm-hmm. So,
I know there's some industries that are very heavily involved with arc cutting or gouging. The rail industry, for example, they do a lot of refurbishment of rail cars, and a lot of them get cut apart and rebuilt daily. There's whole companies that's all they do is cut apart train cars and build them back together. And, those are high-paying jobs, but a lot of that work is very grueling, loud, and dirty because of you're cutting things apart, right? I think of situations like that. I always think of situations like, what about underwater, like deep underwater? Is that something that it could be done? I mean, that's cool.
It could. We often have booths at trade shows, and had some people that came to our tele booth a year and a half ago, and they said, "Hey, Ryan, we've got this application underwater. There was actually some grant money from a government entity that wanted to help further the research of tele or welding without having to send a diver.
That's right.
Down.
I just watched a show on underwater diving and welding, and it's never good. Like, it's at the best case scenario, it's still not great.
Yeah, they make good money for a reason.
Yeah. And if you could have an automated process, you just think like that's a no-brainer, right?
It is. And so, one of those, you ask, what are some other things we're working on, kind of in that same vein as to, why is automation hard or difficult, or what are things to look for? Again, that you want to find those high volume, low mix. And if you can't, it usually comes down to programming.
Right.
When you've got a million different parts that you've got to program, that time to program is significant.
Yeah.
Over the years, I often do a poll where I ask people, okay, what's the runtime on that machine, and how many hours did it take, or minutes, to do that programming? And it usually comes out to be about a 10-to-1. So for every, say, 1 minute of runtime, it took 10 minutes to program that. For every hour of runtime, it took 10 hours to make that program, at least from a welding standpoint.
Yeah.
And so if we can reduce those hours of programming, that
takes out a lot of that time.
That's powerful.
Yeah.
And that's where this recording tele comes into play, some work that the team's doing. We're also doing work on trying to take that programming time, that 10 hours or that 10x time, and how much of that can we cut out?
Shave off, have it almost like modular or something.
Yeah, and there are tools out there. There's a lot of great companies in the CAD
space,
or offline programming space.
Yeah.
We work with several different companies in this space, and there are other opportunities where, how can we expedite that? Not, even in that offline programming space, you have to bring in a model, you have to put it in the right place, you have to do a lot of clicking. That clicking or time is getting reduced.
Yeah.
But there's still some improvement to be done.
Oh, for sure.
There's still time after you do that offline programming. You've got to take that program online, put it on the real robot, and make sure, hey, did everything go well? And that's where the sensors come in.
Yeah.
Is the sensors can say, hey, I took your CAD world, your offline world, and I can now align it to the real world and save you some time.
Yeah. Now, what are some of the biggest, growth spurts or, improvements you've seen in your last 2 years here at EWI, working with the group?
We really enjoy working with the team, cross state.
Between Buffalo,
Between Buffalo and New York.
Yeah.
I started out in the automation team. I'm still an automation engineer. Now in the ARC team or the weld team. And I have the luxury or the opportunity, as
play both sides of the fence there,
to go both places. And we're able to help a lot of customers solve their problems. We've already talked about, hey, how do you look at those problems and attack them? So we're able to come in and do assessments for customers and kind of level set, where are you today?
Yeah.
And give them that view into the future.
Awesome.
And so I really enjoy that. And then on the other end, we get to, develop some new processes, new procedures,
break some new ground. Yeah.
Yep.
That's awesome. Now, for someone at home, let's say, Max, the welder, I'm in my garage. Is there a future where you see, me with my cobot in my garage working together to build, I can pick up a contract for 500 brackets, and I take that contract in my garage and I can work with my cobot, and it will make me be able to make money at a small contractor level, because I feel like that's the space where robotics and automation still don't have any footprint. But historically, you're not really in society till you get to that level, right?
Oh, for sure. It's coming.
Yeah.
You've got these welding cobot ma and pa shops, all the way from the big boys, coming out with their offerings in the welding space.
Yeah.
Most of them offer some type of a cart. And ballpark, a lot of these, you get the cobot with some nice type of a tooling, often
table,
some fixture table with some fixtures. You've got the weld equipment station. Depending on what payloads, what reaches, how high end, low end of a power source or table.
Yeah.
They're between $80,000, $90,000.
Yeah.
All the way up to, maybe 150, possibly even 200 if you start adding positioners,
different hands or different attachments. Yeah.
Yep.
But that's still, compared to 10 years ago, that price has come down considerably.
And if you're willing to do it yourself, you can
even less.
Even less. It's these integrators. We're one of them as well, but they often put some 20 to 30, maybe even a little bit more overhead costs. They got to cover their they got to feed their families too.
Yeah, absolutely.
But if you're willing to do that,
because that's what I think about when I think of like the future of automation. I've had my own company since I was 22, and a lot of the contracts that I would pick up as a small independent contractor were very repetitive, basic things that were just too small of a contract for a big company to take on, because they don't care about a $5,000 contract or a $10,000 contract because it's just too piddly for them. And they're not going to take a welder off a big job just to make brackets. I made custom bracketry for decades. And lots of it was 300 of these, and it was me in my garage welding 300 of these brackets. And for a small contractor, that's gravy, right? That's gravy. You string up one of these a month.
Oh yeah.
You're having a $200,000 a year. That's not a joke. So people are like, "Wow, these little contracts." But you string them up right, and you are having a very successful year out of a little garage and one welder.
Yeah, and if
you can bring a cobot into this,
if you can program that cobot, and not if, it's you can, you can program that cobot to do some of these simple welding tasks. You could, if you line it up with enough parts, you program it in an afternoon. You come back in the morning, there's a basket full of parts.
That's right,
ready to ship.
That's right, and if people are like, well, they make mistakes, but even if 1 in 10 is wrong, that still saved me hundreds of hours. You know what I mean? And I think about that position as a welder in the industry, because I think a lot of people immediately, when they think of robots, think of cobots and automation, they're thinking millions and millions of dollars. They're like, I'm not ready for that. My company cannot do that because that's what the big boys do. That's the big hitters. They can automate. But I think the reality is that it's becoming accessible, right?
Yeah. A lot of your welding shops, so your welding supply house, they're pushing either their own or several versions of these welding cobots. So you go there to buy your wire, your gas, your power source, and
I'll go pick up a cobot, add it to the cart.
Click.
For you, here at EWI, that future, is that a good future? Do you see that as a untapped resource of the everyday hobbyist or the small, ma and pa shops being able to automate? Or, do you see that as business for EWI and yourself? Or are you looking more for like that R&D research kind of development?
The average entry to working with EWI may or may not be higher than some of these small ma and pa shops are willing to do. Sometimes that entry is pretty simple and easy. Mm-hmm. There are often states or localities that offer grants.
Yeah.
And so in that case, we can come and help you, test out and try your application. Mm-hmm. Up in our Buffalo area. We've got,
quite a few toys in there.
Shift 2.0 program. I'll plug that. Where, small manufacturers in that area can tap into a wonderful resource. Great team up there that's able to say, hey, this welding application, this cobots in the machine tending space. That's where they started. Is machine tending. In that used to call it dull, dirty, dangerous kind of jobs.
Mm-hmm.
Feeding a machining center, sitting there, reading the paper or doing something else while that machine is running. You put a cobot on there, and it's just, it doesn't care. It'll sit there for 2 hours or half an hour.
Break. No.
Yeah. So, if you own a machining shop or you're tending some type of machine application, not even a machining center, just is it a press tending? Is it any kind of application?
Offloading materials repetitively or whatever it is. Yeah.
Yeah. One of the first applications I helped implement with this large ag company was a test stand, a cobot. The test on this equipment takes 2 to 5 minutes. Well, an operator has to load that and then go over to another station where the cobot, it can tend or feed 4 to 5
at a time,
test stands at a time.
Yeah. Now, what about the skills required? Like for let's say you're a level 1 welding student, you're coming up, you're just getting into the welding world, and you see people talking about automation and cobots. I hear it a lot that they fear that machine is going to take their job or is going to replace them. Now, I know statistically, data-driven has shown us that automation actually increases the amount of welders we need, increases the number of people we need on the floor. But, what can you say to them to say, hey, this is okay?
Yeah. It's an opportunity to upskill.
Yeah.
Learn a new skill, learn a new technique. It's getting into that point where it's a global environment.
Yeah.
We are needing to, reshore, bring back, bring in, bring home.
Yeah.
A lot of these and a lot of the applications that left. And in order to bring those back.
And they got heavily automated over there.
Yep.
So we got to be on that, right?
Yeah.
Yeah.
And usually what that does is that lower price point to manufacture because of automation brings the opportunity to have more automation come in. And so
increase your output.
You're now, once you were doing 100% of the welding, and now you're doing 5 or 10% of the welding. That's historically what I've seen in the factories I've worked with. It went from the welders doing 100% of the weld to where now they are running several different robot systems, and they're doing about 5 to 10% of the welding in really highly automated shops, and others it's about a 50-50 balance.
Yeah, because there's some welds the machine can't reach.
Yep.
Can't get in. There's certain things that still a human needs to do. And also it pushes the human to be in a much more quality control role, right? Where they're watching the product come off the robot and looking at the welds with the human eye and saying, this needs maybe some adjustment or this might be a little off. Because at the end of the day, the robot doesn't know. The cobot doesn't know. We're getting better with sensors, but they don't know, right?
Or that cost for the automation to know it.
It gets up there.
These sensors cost potentially half to as much as the robot arm itself, and in some cases double.
Yeah, and that's not worth it sometimes for a human to just be like, okay, I can do that with my eyes. Right? What are some of the newer, gadgets or cool things that are coming out for cobots? I remember when I was working with robots when they first came out. Well, no, I'm not that old, but like when we first had one integrated into the shop I was at, it was the True Sight came out, and then there was another one that was the voltage sensors. Yeah. Right? There's always like a new toy that you can add on that helps things. What are some of the new things that are coming out to make robots and cobots easier to use?
The drag to teach feature, already mentioned that. That's
a big jump.
That's the huge jump from that traditional automation. And now, on top of that are these the ability to, can I add some positioners in there with it? That kind of takes it out of this collaborative application, and maybe it's collaborative, maybe it's not.
Mm-hmm.
That's some of the nice, upcoming capabilities, and the other is just mainly in those programming interfaces.
Yeah.
That make it so much easier to program. I use a phrase called "walk up easy." If somebody can walk up to it and quickly and easily, start to use it, that's where the cobots
That's
came in.
a home run, yeah.
Often I would take robots to STEM events, and my 6, 8, 10-year-old kids would help me program a vision system on one of the very first cobots. It was a Baxter robot. I don't know if you've ever seen that. It's kind of gone through an up and down cycle, but it had cameras in its hands, and you'd point it over the, of course, for kids it was candy, or for manufacturing it was a nut or a bolt or a weld sample. And it had a self-learning, self-teaching vision system that you could quickly,
figure it out,
teach it, and then you drag it down and say, hey, here's the pick point of that part you just auto-taught to the vision system.
That's wild. And, that ease of use is obviously a big thing to get it out into the industry more often. But what are some of the obstacles you feel are holding back the integration of automation in industry? There are still huge sectors of industry that are averse to automation. What is it that's stopping people from going there?
Some have said it's because the robotic industry was heavily focused on automotive, which is this high volume, low mix, 1 to 2 widgets.
Everyone sees that production line with the 100 hands moving and a car popping out the end. Yeah, it's like what kind of people imagine.
Yeah.
Right?
So the robot industry, there was an industry peer that had mentioned that they took a sabbatical from their robot company to figure out, why did our robot sales go up and down so much? And they quickly realized, well, it goes up and down with automotive sales. And was like, we've got to break this cycle. And breaking it, he went and talked to a lot of people. And it's true that it was so heavily focused on automotive. And well, why? It's because these
That's
other
not the biggest manufacturing industry in the world. It's not.
Because these other applications, you have that long programming time, or you have these capabilities that just aren't built in. It's not moving to a place and squeezing a spot welding gun or following a seam. It's you've got to sense or find something that may not always be in the same spot, and have to put in a bolt or a nut or some type of seam or attach things.
Yeah, it needed to be. So you felt like the industry hadn't quite kept pace with the needs of or the cobots hadn't kept up, or robots with the industry, and it kind of had to break out of that mold.
Yeah. And the nice thing is I think cobots helped wake up the traditional industry. Like, whoa, here's this new kid. They don't know what they're doing. They're just toys, They aren't fast. They can't carry heavy things. Yeah. Well, hey, you know what? They are.
But that's like when I think of a cobot, and you talk about collaborative, and the whole collaborative world of manufacturing, I almost picture it like a sci-fi show where, here's Max showing up with his toolbox to go to work at the manufacturing plant, and then I meet my cobot buddy there. Hey, cobot, and it's going to be following me, helping me do the things that I need to do throughout the day without it needing a break, and be like, okay, I'm going to set you up to do this. Okay, I'll come back in 4 hours, and then I can go off and do this, and then come back. Okay, you're done. Let's go do this now. That's kind of like, I see like a buddy system. You know what I mean?
For sure. You'd mentioned, hey, you owned your own welding house, and we're like, wished you'd had a cobot back then. And when I first got introduced to cobots, I had just built a home, worked with a contractor to build a home, and it's like, man, there are so many places outside of manufacturing that we could use this. I got a bathroom that needs tiled. Just set it up. Scan the room,
get him in there,
put a glue gun in its hand, or a caulk gun, and a grout gun, and a gripper, and tile away, dude.
And it'll be perfect.
But it's
because I don't do good tile at all, man. It doesn't look good when I do it.
So you'd be surprised in that outside of your traditional manufacturing, it's starting to get into a lot of other applications, and cobots I think will help get us into those spaces because outside of manufacturing, you don't have those cell walls. You need to be mobile. You need to be flexible, and these cobots provide some of that.
They can do it.
Mobility and flexibility and ease of setup. You just literally you
roll it in.
You roll it in. You put it in its Pelican case and roll it to the next place.
That's awesome. All right, last couple questions to wrap up the interview. First of all, in the modern world today, everything that we do, we're trying to be conscious about the environment, sustainability, green, carbon footprints. And I know EWI has that at the forefront of many of its projects that it does here. In the world of automation, where does sustainability and the sustainability of the ecosystem sit within the parameters?
A lot of that sustainability, it's all about reducing waste.
Yeah.
And the robots, they don't go to sleep. They always run. They always work.
Mm-hmm.
If you set them up right, their quality is pretty good.
Yeah.
And so you're not wasting that product. And you don't have to do that destructive testing. At which point in time you may be able to recycle the material, but there's cost to recycle as well. You got to heat it up, melt it down, whatever processing. And so that's the main thing is in that quality, and also not having to scrap out or avoid that waste.
Yeah. And for the last question, what is something that you would like our listeners to know about collaborative applications and robots in terms of perhaps they're not clear about why they're around or the purpose? What is it that you could tell the people about what you do and why it's important?
Collaborative robots, it's ease of use. Don't be afraid of it. There is an industry, an ecosystem out there that is there. They're willing, able to support you. You'd be surprised how good this ecosystem was early on.
Mm-hmm.
The only place you could buy them is from traditional integrators, and they didn't want to touch it.
Yeah.
But the ecosystem out there, many different places to get information about how to program them, how easy they are to set up. All kinds of places to buy them now as well. You used to have to go direct to manufacturer or these very specific channels.
I've seen one on Temu.
there you go.
I'm not even kidding.
You could probably get it delivered next day, depending on the.
I'm not even kidding. I seen one on Temu for $15,000, and I was like, you know what?
Yeah,
I'm kind of interested.
So if I had my own manufacturing facility, one of the manufacturers I worked for was there was a lot of hesitation. Almost 15 years ago to bring on these cobots. And I'm like, these cobots, they cost, $50,000.
Which is a fraction of a traditional robot.
Yeah. We will easily find something for that to do. It may not be the first thing we try, but there will be somewhere that you can find for that cobot to add
I said
value.
that to somebody in an interview. I said, when you look at your staff as a welder, I can look at hiring a staff member and he's going to be $100,000, right, for a decent welder. And I can get a collaborative robot for $50,000, and if it can do half the work, it's
paid for itself.
It's paid for itself.
Yep.
And I don't have to worry about medical benefits. I don't have to worry about pensions. I mean, I'm not trying to devalue the worker, but as a planner and as an owner, I think that saying that it's a waste of money or it's an unreal investment is not the right way to look at it, because staff is an investment too. So it's just a matter of where you want to make that investment, right?
So true.
All right. Well, thanks so much for being on the show today, man. Really like to have you here, and it's a great conversation.
I appreciate it, Max. It's great. Great host. Good conversation.
Oh, God. All right. For all the people that have been downloading and watching the podcast, please make sure you check out all the special ones we did here at EWI. They've been tons of fun. And from here on out, make sure you download, share, and comment. We're always looking for more questions and more more conversations from the industry. So thank you very much, and catch the next one.